Hello, everyone, and we are live. Welcome to our AMA, where you'll get to chat directly with the team building our OpenTelemetry support. Yes, welcome, everyone. I'm Sasha. I'll be your host today. Before we start doing intros, we'd love to hear where you're all watching from, and if you want, you can add in a little bit about what you're most interested in learning about today. So on our side, we have teammates from Vienna here. I'm in SF. We also have our teammate in chat from Washington. So we're quite a dispersed team and really looking forward to seeing all the questions that you come up with. So while you're all still adding to the chat, I'll go over a quick agenda for today. Abhi, if you can just, awesome, thank you. So we're going to kick things off with a little bit about OpenTelemetry and how Sentry supports it, and then we'll dive into a live demo so you can see it in action. And before I hand it off, please remember to drop in your questions in the chat. And oh, awesome, Finland, hello. We're going to, so drop in your questions in the chat, and we want this to be an engaging session. And the best way is, or at least from what I have seen in the past, is when you all send us your chats throughout. So really quickly, just for folks that are new here to Sentry, I'll just share a quick one-liner of who we are and what we do, and then I'll pass it over to the team. So really quickly, Sentry is an application monitoring platform focused on helping developers see critical issues and solve what's urgent faster across their entire release cycle. So that means errors, performance issues, and also code coverage. And it's all integrated into a single workflow so that you can get in and out as fast as possible and back to writing and shipping code. So with that, let's jump into intros so you can all meet the team. Let me just add them real quick. Hello. And Daniel, why don't you start us off?
All right. Hey, I'm Daniel. I'm here coming from the Austrian countryside. You would see the Alps there, but right now it's already a little bit foggy. So I'm working at Sentry and I'm here since last July. Before then, I've almost a decade in experience in the observability and the monitoring space. And now I'm working with the team on the telemetry product. So these are all the SDKs and everything around that. And I had a little bit of a background in OpenTelemetry when I started. We'll tell you a little bit more later. And there were already ongoing initiatives when I came into Sentry, and I then worked with the team to get to the point where we are today to show you what we can do with OpenTelemetry now. Steven.
Yep. So I'm Steven Eubank. I'm the product manager for web SDKs at Sentry. So I'm the guy who Daniel came in and pushed to finally do this OpenTelemetry work at Sentry. What that basically means is I'm responsible for JavaScript SDK, Python, Ruby, Go, PHP, on down the line. And one of the folks that I work with to actually deliver those features is Abhi here.
Hey, I'm Abhi. I'm a senior software engineer here working on the web SDKs. So all of those languages, helping build the SDKs here. I'm here at Sentry for, it's about to be 2 years now. And actually, before that, I was an intern here at Sentry, where my intern project was working on OpenTelemetry. So I've been kind of here at Sentry since we started doing this OpenTelemetry work. So excited to show off what some of the stuff we have built over the past couple months.
Awesome. So you all are the experts here at Sentry. You're being modest. So why don't we jump into the first part of this session, which is what is OpenTelemetry and why does it make sense to use Sentry and OpenTelemetry together? Daniel.
All right. So I'm giving a very brief history lesson here, but I think it makes sense to understand why we are where we are today and where all this was coming from. And everything started basically with the monoliths back then. So for a long time, monoliths were the thing. You see that here, and also the very nice monoliths of Odyssey 2001. And everything was easy for developers because now it's Avi. I think we need the slides. Yeah. Everything was easy for developers because basically when there was a problem, you just could attach a debugger to it or look into the log files. So there was not a big problem. And also distributed tracing was not so much a topic. Performance monitoring tools back then were really focused on in-process stuff. Yeah, and then we had a phase, this was around 2005, where distributed tracing was slowly coming up with service-oriented architectures. We all maybe remember SOAP and XML and all that stuff. Yeah, and there, the first time it got important to understand how like different services are calling each other. And this was the inception of all the tools that came out around the legacy tools around 2005, 2006. So Google did the DEPA paper where they described how to trace things. So this was the beginning of that. And then a few years passed and SOAP was not longer a thing anymore. And we ended up now, yeah, where suddenly, so now, like in 2015, we saw the rise of microservices, right? And microservices now actually are a good way to architect applications. I mean, Elon Musk has another opinion on that, but yeah, that's a philosophy topic. But there are a lot of now big microservice deployments. And the challenge here is now you have a lot of small services handled by usually a few teams. And all those services are now connected over the wire and communicating over the wire. And to make things a little bit more complicated, you also have all these services that those things connect to. And these services are also very often opaque, like some AWS Lambda, etc. So that's a challenge. And when I started around 2015 or so, I was told, monitoring, that's nothing for developers. They don't care about that. You have to focus on operations. But what I saw over the years, and I'm also happy that Sentry is right there, is that now with microservices and the complexity of all those things, suddenly developers care about this because their own service is so isolated. They need really to know what's happening downstream and also what's happening upstream. And this leads us, next slide, to what distributed tracing is today. Yeah, I want to see a user action, someone does something, then this trace or this transaction makes its way through all the tiers. And if maybe service A has a problem, then I want to know about it. I want to understand. And even if I'm the front-end person, yeah, I just, and someone tells me, oh, you know, this button does not work, I want to be in the position to say, let me see, yeah, that's downstream the service A, and then I can call this person that is responsible for service A to know really in complex environments where the problem is really occurring, where the root cause is. That's the purpose of distributed tracing. Next slide. And so now we are fast forwarding to 2018 and 2019, and this is when OpenTelemetry enters the stage. To give you a little bit of history, so OpenTelemetry was not the first open standard in this space. So it started very early, like in the 2010s or so, with, for instance, Zipkin, and also, but that was by Twitter originally, or Jaeger, which was by Uber originally, where companies tried their own thing to do distributed tracing and to and monitor using traces. And they made them open source projects. Yeah. At the same time, there were also vendors already around which did distributed tracing. So it's not that OpenTelemetry now invented this space, but what happened in 2008, around fall of 2018 was remarkable. So I was working at W3C Trace Context. So this was the initiative that basically deals with how to do trace propagation, creating an open standard. And then we saw suddenly that we saw that there are several standards around, and the same people behind Open Sensors, namely Google, and Open Tracing, namely Lightstep, were also in this group. And we were already discussing, it would be nice if these projects would be merging. And they really started talking. And at some point, and this was at KubeCon 2018 in Seattle, they said, hey, we did something. It's called OpenTelemetry. Now we will merge those projects, because it does not make sense to have several open standards, because no standard will ever make it. And so OpenTelemetry was incepted in then early 2019. It joined the CNCF, and since then it constantly grow, and now it's the second largest project after Kubernetes in the CNCF. Next slide. To give you an impression of OpenTelemetry in a nutshell, I have this architecture diagram that is shared pretty frequently here. And the takeaway for you is OpenTelemetry is a very extensible platform. Yeah? You can even switch out the whole SDK and just use the API, for instance. You can plug into the processing pipelines, which we are doing, and you will see it in a second. There are exporters to export to other subsystems. There are ways to use collectors with it and export from there again. So OpenTelemetry was really built around extensibility. That's important, and that's also why all the vendors were very happy about this standard, because it gives them a lot of possibilities to use it. Next slide. With that all said, so what does OpenTelemetry not provide? Yeah, because sometimes it's also a misconception there. So OpenTelemetry does not give you a backend to store the data. It does not give you analytics on top of this data, and it also doesn't give you a user interface. And that's not a bug; that's all a feature. Yeah. It does not do error monitoring like what you know from Sentry, the stack tracing, fingerprints, grouping, all that. That's not part of OpenTelemetry. And also, I mean, that's maybe a little bit a bug. It does not have proper front-end monitoring today, because it really focuses mostly on the backend. Next slide. But what OpenTelemetry provides is auto instrumentation for many platforms and frameworks. And this is important, because as a vendor, you constantly try to reverse engineer existing libraries to understand them and to monkey patch them, to collect traces from them. And with OpenTelemetry, this is kind of collectivized. There are now many vendors are working together to create proper instrumentation. Everyone uses the same, basically. It provides a unified way for libraries and components to add observability, which means the goal of OpenTelemetry ultimately is that you don't have to monkey patch and auto-instrument at all, but the libraries come with basically with batteries included. It provides, also important, an SDK for vendor-neutral manual instrumentation. This means that sometimes auto-instrumentation does not fully cut it, especially for JavaScript. All those dynamic functions are not picked up. And to monitor them, you have to add your own instrumentation. And people are naturally reluctant to add their code, their instrumentation as auto-instrumentation for specific vendors to their code, because your code base gets littered with vendor-specific code, and if you want to switch one day, that's really problematic. So that makes a lot of sense to have a unified SDK for auto-instrumentation. It provides a data exchange format called OTel, all in protobuf, defined very well, perfect, and also it provides a way to send data to multiple observability backends, which is important because SRE has a different use case than a developer has. Yeah, SRE might use a different tool than developer wants to use. Yeah, and with that, with OpenTelemetry, you can use one instrumentation, and one way to collect data, and then send it out to different backends, and that's really a big win. Next step. So I talked a lot. That's the last theory slide. so what's Sentry and OpenTelemetry? Abhi created an exporter. I put in 2021. I hope it's right. Was it 2020? I don't know.
Yeah, around then.
Around then. He created an exporter, but it has its limitations. Yeah, and so we decided not to recommend it to all customers in all cases. Yeah, so it's more experimental. And in mid 2022, we started the OTel support that you see now. And now you just have to use a few lines of code to combine Sentry with OpenTelemetry, so to connect those two SDKs. And with that, you get basically all the observability and distributed tracing and error monitoring all out of the box. As also, this is right now available for Node.js, Python, Ruby, Java, and Go. And I think .NET is coming, right?
Yeah.
It's on its way.
Okay, good. So that was it about the theory, I guess. And I'm now handing over to Vienna, the studio in Vienna, for showing you how this really works on screen and on terminal.
Yeah, thank you, Daniel. So I definitely learned a lot. That was great. It's a perfect follow-up. Yeah, really the important thing to call out here, Daniel touched on it a lot. It's just about plugging in the SDK and a few lines of code. And the two pieces that are most important there are the Sentry span processor and Sentry propagator, right? So this is all that we really need to connect the Sentry SDK to your OpenTelemetry SDK. So all these things we were talking about, you don't want to deal with the complexity of instrumentation twice, 3 times, 4 times, as it's just the standard. There's a large number of organizations in the world that are using multiple observability vendors at the same time, whether it's in-house or SaaS vendors. So we want to make sure that that's easy. And in this case, it makes sure that you only have to instrument for your performance data with OpenTelemetry, and then you plug and play with Sentry. And we'll show you that live. And this gets into a little bit of how that Sentry SDK is set up, right? So we are within your application. And if you remember back when Daniel was talking about Abhi's, one of Abhi's intern projects, he was also not talking about all the stuff he did. The exporter is ultimately on a collector that is outside of your applications, right? And we want to be inside because the Sentry SDK is still providing a lot of value that customers expect. And so we run alongside, but we simplify it and make sure that you only have to instrument for performance. And then we send all that data to Sentry, and you can continue using any other vendor that you like.
Yeah, I mean, so that was a lot of talking. So let's get into the action a little bit, show off kind of how this works, how you can add it. In the chat, there was some great links already to some of our documentation and open stuff on GitHub that you can also check out. But we'll show a little bit of this here. So right on the screen, you can see this is the official OpenTelemetry demo with a bunch of microservices written in all different languages, all wired together. And the idea here is these are all producing OpenTelemetry data that you can see and kind of visualize the trace through these systems. And we've gone ahead and added Sentry to some of these services so that you can send that data to Sentry and see how it shows up.
But maybe just like a little bit of background on this suite of services, right? So this is kind of overcomplicated by design, and this was from the OpenTelemetry project, and they wanted this suite of services and polyglot to the extreme to represent all the different things that might go on in your typical like B2C microservice setup that very many customers have, maybe not quite so polyglot, but this allows for many organizations like us to create a fork of it, and that's what we've done, and they're sharing in the chat here so that we can test it out and make sure that everything works the way that we expect it to. And then if you ever want to see an example, you can go and look where we were ultimately playing around and hopefully copy and paste a bit and get it working in your own setup.
Yep. So yeah, live demo. Let's give it a try. I have just a nice Sentry project here. You can sign up for Sentry for free, developer plan, send us a bunch of your errors and transactions. And this is what I have right here, a free developer plan. And I'm going to try to, I have like a gRPC example that actually comes from OpenTelemetry themselves. So this is the official OpenTelemetry JavaScript repo where they kind of have their instrumentation. And this is kind of their official OpenTelemetry gRPC example. And so let's try adding Sentry to this and see what this looks like when it produces some performance data. So you can just create a project. In this case, we know it's JavaScript, it's Node on the back end. Let's just call this Node gRPC. And cool, so the project is created. We'll come back to this screen. I already did the work of like cloning the repo because it's actually quite large. And want to minimize things that could go wrong here. But let's try just adding Sentry. It's pretty simple. Well, the first thing we have to do is npm install, of course, the package. In this case, there's two packages for JavaScript, our regular Node SDK, and then our kind of OpenTelemetry features. But in most other SDKs, like in Ruby and Python, you can just install our Sentry SDK and get all of kind of our OpenTelemetry span processes and propagators out of the box. So I run this, and this will take a while because it's the JavaScript. Oh, actually, it's quite fast, probably because it was cached. And I totally did not do this before.
First time today?
So here we call, we require the Sentry SDK, and we can just call init. Init needs kind of a couple things to work. It needs, of course, a DSN. That tells you where to send it. In this case, we can just copy it over from here, our project. Normally, in production, you don't want to hard code this, use an environmental variable or something, but just a demo. We have to basically tell Sentry that, hey, we're using OpenTelemetry and not Sentry for our instrumentation. And then we want to give it a sample rate, which is how you basically enable sending performance data to Sentry and configuring how much of that data you want to send. Because not every app wants to send every single piece of performance data they generate from their app. Cool. And so with that on the way, that's basically just the Sentry setup. We're good to go there. Now we have to add just a couple lines of code to make it work with OpenTelemetry. So we have another package here, OpenTelemetry node. And from here, there was two things that we need that Stephen mentioned. There was the Sentry span processor and the Sentry propagator. Again, the span processor helps us kind of do this transformation of format. And the propagator makes sure that distributed tracing works properly.
I think it's like interesting to note this conversion that we're talking about. In the end, OpenTelemetry's data model and Sentry's data model is not so different. That makes a lot of this very easy. And Sentry's data model for performance and OpenTelemetry ultimately evolved in a similar time span. So it makes sense that a lot of it works that way, and it made our life, or Abhi's life, probably easier when he was designing all of this out. So just say, okay, everything that comes in a Sentry span, you copy it over and you put it into these fields in Sentry.
Yeah, so like actually, so Daniel Kahn was mentioning before about like the OpenTelemetry evolving from OpenTracing. And our performance product actually also similarly very much evolved at the same time as OpenTelemetry was starting from OpenTracing. And so a lot of like the key concepts like spans are the same. And even actually like the fundamental parts of our schema, like trace IDs, span IDs, timestamps are all typed the same way. And they follow the same formats. Makes our job way easier. So continuing, we can add the Sentry span processor here. And then we just need to add the propagator. So the way this works here is in your provider, you can add a propagator. And there you go. With these two things, I now have data being generated and sent to Sentry. And I have distributed tracing all hooked up and making sure that'll work at Sentry too. Awesome. And now let's run it and see what happens. So according to the README, I have to run the server and then the client. It's basic, just two services. So I'm just going to copy and run it.
Abhi, while you're doing that, we do have a question. what does set global text map do? Won't that steamroll all of the other propagators?
Yes. So there is the case where if you're using another propagator and our propagator, you wouldn't want to override it. But I think there is a way. It depends on kind of the specific OpenTelemetry SDK that you can use both together. The nice thing is, under the hood, the Sentry propagator should just be extending from the W3C propagator that most SDKs just use naturally. So we won't get rid of the W3C trace context or the baggage header. So we won't squash those two. But as for the specific details, yeah, for Python, I think we would have to take a look, but maybe we can explore afterwards and see how that looks like. I'm sure there's a way, because yeah, we wouldn't want to kind of squash the other headers.
I think, Alex, I was in Helsinki last week, so we could have met in person. But he has another question in there about what does a Sentry SDK ultimately add outside the OTel. And that really, it depends on the platform, but a lot of that gets into a lot of the features that you know and love, and we'll get into that later in the demo. So in Node, it's not the case, but if you want to have replays, you need a Sentry SDK, but that's in the front end. If you're in Node or you're in Python and you're looking forward to profiling, for example, then you need that. A lot of the features that you get out of a rich issues experience, you get out of the Sentry SDK running next to your OTel SDK. So some of what you're mentioning there, but we can show examples of this later.
Yep. And so cool, we have performance data showing up. In the Sentry view, you get kind of nice breakdowns of these higher level important spans we call transactions. So normally these would be things like a request that your HTTP server serves, or an entire queue job that was processed. And as well as looking at like some nice high level aggregate statistics, you can dive in deep into the span waterfall, which is super interesting. So this is what was happening on the server. In addition to kind of all the nice context you get from Sentry about the device, about the node version, you also get the OpenTelemetry span attributes. And we can see it all hooked up in a nice distributed trace. So this is the kind of client-side gRPC call, and then the server that responded to it. So if we take a look at the client-side call, we can magnify, it's auto-grouped, and kind of see like, hey, look, this is what was happening in the client, and these spans are what was happening on the server. But all of the kind of other stuff that you like about Sentry performance is still there. You get your breadcrumbs, you get your tags, you get your context. And so that's how easy it is, basically. We weren't even really that focused. We got sidetracked a little.
You don't admit that now.
Okay. But
one of the other cool things for us, like what did Sentry get out of this as well, right? Like we also benefit from using OpenTelemetry. We're looking at gRPC communication here, right?
Yep.
When were you able to see that in Sentry before?
Yeah, so we basically, our kind of performance monitoring functionality we built was heavily based around HTTP connections, which you can still make work if you manually instrumented your apps. But with OpenTelemetry, people already built this for us. And we can kind of leverage that data and just send it to Sentry, right? Which is super useful.
Which gets into what Daniel was talking about in the beginning, right? Like the benefit of this being a popular open standard where so many open source users, companies, doesn't really matter, are interested. That means that all the investment that goes into it, we get benefit as well. And we also are interested in the growth of OpenTelemetry now, as it just, like, right, the OpenTelemetry by design isn't going to have a backend, it's not going to provide you these insights, and we can put that structured data into our system and start seeing it. So it's exciting for us as well, because we didn't have to build all that support in every SDK. We just have it now.
So this was linked a couple times in the chat, but if you could link it again. We have docs for all of this that basically follow the same process of you install the package and you call Sentry, and then you add the Sentry span processor and the Sentry propagator. And yeah, if I took a look at something like Ruby, works the same way. So you call Sentry, and you use the span processor and propagator. Cool.
It's just less because Ruby.
Yeah, it's there's no, you don't have to worry about all those imports. So, I mean, maybe we look at now the OpenTelemetry demo. So Stephen touched on this, and we kind of showed it off. There is like this OpenTelemetry demo that has all of these microservices hooked up in different languages. And we have a fork of it where we added Sentry to some of these services.
Or we added it to over 10 now.
Yeah.
I think it's maybe even around 12, 13 services in total that we have hooked up to.
Yeah, some of the services are in languages that we don't have SDK support for yet. But in everything that we do, yeah,
So
.NET. We'll get around to it. There was a question. Is there support for OpenTelemetry logging and metrics as well?
Ultimately, Sentry's not logging and metrics focused. And so logging and metrics is not part of what we plug into.
Sentry does not only just do error reports, we also do the performance view. So from OpenTelemetry, we grab the traces with like the traces signal is what they call it. And we turn that and put that into our performance product. Maybe actually let's look at some example.
A good place to jump into is what we've instrumented here. So what you didn't see in some of the examples or the example that Abhi just showed, but we will see in some of the other traces is, right? So what was asked in the chat was like, if Sentry is only for error reports. And at Sentry, we're very happy that people love us so much for error reports, but we do performance as well, along with some other features. But performance is powered by OpenTelemetry. It can also be powered by SDKs, and those can have errors associated with it, right? Not every trace is going to be a flow of everything being 200 okay and good. So there are going to be situations where you have that error, and the reason why that we were mentioning earlier that you get this value of the Sentry SDKs is we can link in that distributed tracing model from your transactions to those errors and what you're used to seeing on the issue reports.
Cool. Yeah, and here you can also check out we have a Go SDK with support for Go as well. But maybe let's go see how this is all wired up under the hood. Or I guess not under the hood, over the hood. So this is another gRPC example that comes from the OpenTelemetry demo used to be called the hipster shop. So
maybe pop back to like one level higher real quick.
Do you want to see more?
Yeah, just so people see the idea here, right? So we have more stuff in there from, this is the SDK's team's playground, let's say. So there's plenty of projects in there you maybe don't care about. But as you scroll through, you're going to see a lot of different platform icons. And this is not error reporting. This is not specific to errors. A lot of these, it's just purely monitoring your applications, your API requests, database interactions, seeing how healthy they are. And we're able to now plug that in with OTel. And the example that Abhi will get into will be with one of the hipster shops. If you're confused, because it's the OpenTelemetry shop, it used to be called the hipster shop. And we've kind of stuck with that old name.
And so here is the checkout Go service. And we can kind of see the single transaction for this and all of its kind of nested spans, including some of the calls, the RPC calls that are made to other services, and even a message to a Kafka topic.
Mm-hmm. Can we show real quick going through the OpenTelemetry telescope shop?
Yes. Though I know I have to go look at the link. Go find the link because I lost the copy paste.
No problem. You couldn't make it through an entire demo with no problems like that. You didn't want to tarnish your record.
So let's go look at our production demo here.
Yeah. So this is what that big suite of services, that's the front end of it. So this is how you can go through, and it makes it very easy for us and everyone else to go and play around. So we'll just click through and show buying a telescope.
Yeah, so add to cart.
And already what's going on here, for example, is the JavaScript browser SDK, or in this case, it's the Next.js SDK specifically, is capturing information and sending it to Sentry. Session replay is turned on, for example. And if there's an error, that would be sent to Sentry as well.
And so just as an example of looking at this error, let's say I wanted to buy the comic book, less than $1. So this is quite the steal. And I click add to cart, and this works. And I try to place order. I'm clicking, but nothing is working. I can try clicking multiple times. If I went into the console, I can actually see that like there seems to be just a bunch of warnings here that are coming, some JSON parse warnings.
But your comic book purchaser probably isn't doing this, and they're not going to call you and tell you. So good news, Sentry will tell you.
Yep.
And that's what we can show off.
And so yeah, this is like quite a big problem. And so actually, if we went to like the issues page, if it'll load.
That wheel always feels much more painful when you're on camera.
I know. This is kind of the error actually that's being thrown in the front end. There's like a 500. And if we wanted to see the error that's happening in the back end, it's actually coming from this Go service that thinks that the product is invalid. And here actually you can see that this is again in the Go service, this checkout service. This is the issue. And we can actually trace not just transactions and spans together, but a Sentry error to OpenTelemetry transactions. And so if we took a look at, let's actually look at the entire trace.
Mm-hmm.
You can see here that like when we tried to check out with the Next.js app, and so we just called post checkout, this failed and caused an error. So here they just you can see, oh, there's an invalid order, invalid product, and it shows up actually as part of our distributed trace. So if we just went into this pretty simple transaction that's happening in the front-end service, it's basically just attempting to call the checkout service, but that's erroring. And now we know that's happening because the checkout service itself has an error in this prepare order items span. And so this way you can kind of get an idea of, even if it's a little opaque, of an error being thrown in the front end, you can get an idea of maybe it's a backend service that was responsible for it. And you use kind of you trace down your spans to see exactly which service was causing your front end problems.
Maybe now we can go back to like one of those larger traces from the successful order.
Yeah, let's check actually. I think this is quite a big one.
Nice big trace.
Yeah, and so this is a successful order from post checkout, but actually the processing the orders in this fraud detection service didn't work because we threw an exception on purpose. But just as to illustrate an example, actually, like we had a successful checkout, like somebody hit checkout and it hit all the services and it seemed to be fine. And maybe if you were just, monitoring only your Next.js service, you thought, hey, okay, everything is fine. But because of this distributed trace, you can now see that like, no, actually something went wrong here. In my fraud detection service, after all of these other services were hit, and maybe that causes like some impacts later on, and that is not immediately like apparent, but will come up afterwards. Mm-hmm. Yeah. So, anything else you want to show off?
We can maybe show like a replay for this. A lot of this is, like I said, for people who are really used to the errors product, or maybe missing out on something like performance and their observability tools. And now Sentry with OpenTelemetry is just complementary, right? So it's more and more value that you're going to get out of Sentry. And this next thing is something again along that line, right? So this is session replay, which again, as we propagate the trace, we use OpenTelemetry, we're connecting the errors, we want to connect everything. So we're continuing to connect with session replay. And this is, as you can see here, it's anonymous by default. So we're focusing on, we don't really want to know what's on the text or what users are typing or what users are doing. We just want to see how an error is occurring and how it's connected. So again, you see that nice big trace view and all the different services. And you can actually see multiple traces if it occurred throughout the session of that user being logged in leading up to an error.
So here we can see that like, hey, just loading the page, it made some requests to our API and then our downstream services. This seemed to be fine. But around the time that we were getting errors thrown in the front end, we had some problematic transactions. And this kind of helps you link what your users were doing in your front end. This is instrumented with Sentry's replay SDK running in the browser to your OpenTelemetry data that's happening all across your services around your entire backend. And so suddenly now you can even connect individual user actions or user errors and see kind of if it was a backend service that was impacting that. I mean, we can even show off profiling.
Yeah, so profiling, we don't have like an exciting use case from the hipster shop, but of note, and like replays is connected in the browser to the backend services that you might be powering the performance product in Sentry, but you can see how we try to make sure all these things tie together. Profiling is no different, and now that's coming out on more platforms at Sentry, and here we have a beautiful profiling example.
Yeah, so this is like a super simple Python example. And part of the reasons why it's actually so simple is because if we go look at the actual recommendation, if we look at the recommendation server itself, it's actually like a pretty simple service that there's like nothing much going on. In fact, like this get product list is pretty much what's happening. So not a very complicated profile. But the great thing here is you can run a Sentry profiling or Sentry SDK that will enable collecting profiling data alongside your OpenTelemetry data and kind of connect profiles to spans generated by OpenTelemetry. And then further kind of understand how those are involved with like a wider trace. So here we just went from a profile, which was like individual function calls and stacks, to a span, which showed kind of what's happening on the service, to an entire distributed trace. And this is kind of the same flow you can do by adding profiling to any of your OpenTelemetry instrumented services as well. Cool. I mean, that's pretty much it with the demo.
Awesome.
Sasha, you've joined us.
Fancy
Yeah,
slides.
I'm here. I've also added Daniel, so we're back to try and answer a few of the questions that we have, both from our registrants as well as live. So please add in your questions in the chat. So first question, and this kind of came up earlier as well when we were talking about the concept of a trace, and you all mentioned it here when you were talking through performance as well as profiling. What is the difference between a transaction versus a trace?
So, I mean, trace is ultimately like an overarching concept, right? They're not concept, but it's a construct. So every transaction that you're creating in Sentry, or if you're more familiar with OpenTelemetry terms, it's spans. So transactions are a vessel to group spans. And then we actually enable what we're calling distributed tracing with putting this trace ID on each transaction. And then also on session replays, on errors. So transactions are specific to spans. Traces are how you connect all these different communications across your services.
So like, yeah, multiple transactions which have spans inside them put together will result in a trace. But a trace doesn't just have to be, as Steven mentioned, made up of performance data. It's kind of made up of events that are happening to your application as it's running, right? And so a great thing, and a thing that Sentry is really good for, is to link your errors that just happen during your requests in your front end and trace them from your front end to your back end and kind of see how all of these different services in a modern kind of technology stack interact with each other. And this is really hard to debug sometimes because you also have to kind of correlate the requests to each other, right? If you're just looking at plain logs, it can be really hard to tell like which was the exact request that was started from the front end that kind of caused all these issues. But if you have like the trace that goes and all the individual transactions, this one's pretty easy to figure out, hopefully.
Which it's good. It's a good point as well, right? Like logs are ultimately just like the endless flow of data, and what we're really trying to focus on is that the transactions are ultimately providing you the value data that you're going to use to make decisions in the performance product, and the trace simply connects all those together across your services. And we make sure that it's the data you send to Sentry is the data that matters.
Great answer. Thank you both. Next question we have from Steve, who registered. Can we use this with the OTel collector Lambda layer for Python in AWS Lambda?
It's a good question.
I'm a little bit confused by the question. The OTel collector Lambda layer. I think if your question is, do you want to work with our Python SDK with the OpenTelemetry integration that's already working on AWS Lambda, the answer is yes. The OpenTelemetry collector is a different thing.
Yeah, and there's also, AWS also released a layer which you can basically install OpenTelemetry layer, yeah, which you load into your code, and which also supports OpenTelemetry. This we don't support at this point because, yeah, we have working Lambda support. Would be interesting to get more use cases around Lambda, yeah, and if we see demand, it's definitely something to be explored.
Cool. Steve, we'll reach out to you so you can share us a little bit more about your use case, and so we can hopefully help support. This question, how does this support compare to other vendors? Daniel, do you want to take this?
Yeah, I mean, the observability space is big and involves a lot of personas. Yeah? While maybe marketing and PMs want to see like behavioral analytics, SREs want to see how their infrastructure is working, the Kubernetes pod spinning up and down and all that stuff. Yeah? And then there are developers, yeah, those people that are creating the code, and they have also very specific needs. Yeah, so Sentry is a tool for developers, yeah? And the lens and everything we do is focused on developers, and I think that sets us apart from this observability tools that we see today on the market, which are mostly focused on SREs and operations folks. Yeah? And this is not an us versus them, but with OpenTelemetry, as I said before, you have a way to just send data to both backends, to the vendor and to Sentry, and make everyone happy. And it even gets better because we are using the same, for instance, trace ID for all the things. It's possible to pick up a trace or information from one tool, yeah, and then just look it up in the other tool. So there is an easy way to go back and forth. Because what I have not seen in any organization ever, though many act as if it was the case, is that an organization uses just one tool for observability. This is just not happening, but for a little bit larger organization.
Awesome. Thank you, Daniel. So we have one from Alex. Keep the questions coming. Is there any benefit to using the Sentry exporter for the OTel collector versus just sending traces directly from the app if the app needs explicit instrumentation anyway?
So I think we really recommend, although again, as was mentioned before, the exporter is a possibility. I think we really recommend including our SDK in your service running alongside the OpenTelemetry SDK. This makes sure that you kind of get the best view into your data, and that errors are correlated to your performance data and your spans, which is like super valuable and makes debugging way, way easier.
Yeah, I mean,
one thing I like
really
to add here, or should I? Yeah, okay, let me add this real quick. One thing I like to add, recently we heard about a use case which really justified the exporter. This was someone using Istio on Kubernetes, and they did not want to instrument any of the applications. Istio is a service mesh. So it connects basically like a switchboard, one service to the other. And there, this Istio emits OpenTelemetry, and you can send it to an exporter. And in this case, it makes sense also because this scenario also works around the limitations that you may have with the export in other cases. So that's a valid use case for that. So there are reasons, but use the exporter wisely.
Yeah, I was basically going to get into that use case to some extent, because the caveat to that as well, what was described, emitting OpenTelemetry data for that specific scenario also meant that a lot of the performance data that you might have seen and been like, oh, I want to get into that, isn't there. It was really purely inter-service or intra-service communication. So this was a very high level, which makes sense. And that's what they needed. And so it's like, if you don't have the option to add to the app for whatever reason, then that maybe is the way for you to go. But it doesn't necessarily mean that you're going to get all the value, because they're not getting that out of OpenTelemetry at all anyway. It had nothing to do with, just was their only option, basically.
Awesome. We have one more question. Do you support mobile?
Short answer is no. Part of that is because, as Daniel was saying in the beginning, OpenTelemetry doesn't have a ton of support in front end, and that includes mobile in this case, right? There are some OpenTelemetry libraries out there for mobile. They're varying support in our discussion, which I think has been linked somewhere. I posted in there kind of summary of the different OpenTelemetry libraries and which ones seem to be more popular. And that's something similar to what Daniel was saying. We had a call with a customer, and I'm pretty happy to tell them there's going to be scenarios where maybe the OpenTelemetry SDK support on some platforms is going to make sense. But in many cases so far for mobile, we just have way better support. And again, because of the way this is done in process, essentially all the transactions, traces, spans play well together. So if you instrument with Sentry and your mobile SDKs or your mobile applications, and then you're instrumenting with the OpenTelemetry Sentry mix and your others, all those things are still going to come together in Sentry.
Yeah, and to be clear, I guess we have Sentry itself and our Sentry SDKs do support mobile very well. We have SDKs for pretty much everything, from Flutter to Android to everything in between.
And also front end. So, well, you have quite a breadth in backend libraries and support in OpenTelemetry. I mean, our support for front-end tracing, to be very honest, is still unmatched for all those JavaScript things that come out and like on a weekly basis. There we are well ahead still. Yeah.
Great. Heavy +1. We support across platforms. So I think we are running out of time, and it looks like we don't have any more questions. So quick reminder for the folks still with us, please fill out the survey, join us in our discussion on GitHub as well as Discord. And if you have any other questions, you can reach out to us there. But other than that, thank you all so much for joining. Thank you, Daniel, Abhi, Stephen. You all are the dynamic trio.
There was many other people involved in building this stuff.
Yeah, it wasn't just us. Definitely not. So, there's a lot of
thanks to everybody else on the team.
Yeah.
Thank you. Hey, thank you, Sasha.
Thank you
Abhi,
all.
Stephen.
See you at our next
Yeah.
one.
Thanks, folks.
Bye.
Bye.